Hi Year 12s. This video is designed to cover section 4A of the Cambridge textbook, which is the squared transformation. When we finished chapter 3, we modeled linear associations between two numerical variables. So let's say we had a scatter plot that looks something like this. We had a line of best fit. And that worked really well when the association between the variables was linear. As you will have seen, most things in the real world are not linear, and so while this technique is very useful, it's also limited. We can expand the scope and the usefulness of linear regression by performing what's called a transformation to the data. In this course, General Maths, we will confine ourselves to applying that transformation to only one of the two variables x and y. We will know that we have been successful if, after the transformation, we generate the residual plot again, and we find that there is no longer a clear pattern. When this has happened, we say that the data has been linearized. So, in chapter 4 of the Cambridge text, we introduce three different transformations to the data. So you've already met the first one. It's called the squared transformation. The next one is the logarithmic transformation. And the final one, probably the one that you're least familiar with, name-wise, is what's called the reciprocal transformation. Reciprocal is just a fancy name for inverse, and inverse in the sense of multiplication. So you'll see in red, I have highlighted the variable that has gotten the transformation. And what I want to emphasize here again is that we're only doing this to one variable at a time in general maths. And so essentially, that gives us only 6 options if the linear model didn't work. Now, you might be asking at this point, which transformation should I pick? It's not immediately obvious, and in general maths, we don't really study nonlinear relationships in the same way that we do in other courses like maths methods. So, while this video is focused on section 4A, I want to very, very briefly just jump to the first page of 4D, and you'll see that in that section, the authors give a diagram which they call the circle of transformations. And depending on the curvature of your data, there are different transformations you can try. So for data that is increasing from left to right, but increasing slower and slower as you get further to the right, the transformations that are suggested are to square y, to take the logarithm of x, and to take the reciprocal of x. On the other hand, if your data is increasing, but the rate of increase is getting higher and higher, the transformations which are suggested are log of y, 1 on y, and x squared. If your data is decreasing from left to right, and the rate of decrease is getting smaller and smaller, the transformations which are suggested are log of y, 1 on y, log of x, and 1 on x. If your data is decreasing and the rate of decrease is increasing, then the transformations are log y, 1 on y, and x squared. Now, if I were in your shoes and I were looking at this diagram, I would have two questions. First question is, how did you know to pick these transformations? Why can't I just use every transformation in every part of the picture? Unfortunately, we're not able to answer this question in general maths, But if you're taking maths methods, you should recognize some relationships such as parabolas, square roots, exponentials, logs, and hyperbolas. Um, and I leave it to you as an exercise to try to justify some of these claims. The other question that you might have is, do you need to remember this? And my answer to this question is no, because you're allowed a bound reference in every general maths assessment. So I personally cannot remember this diagram because there's too many transformations and too many possibilities. So I would have this on hand straight away in a SAC or an exam. Probably near the front page because I'll probably want to refer to it. So that's all I'm going to say about 4D. At the end of the chapter, you are given the data and you've got to make the choice yourself. But for the first 3 exercises, the authors of the textbook have allocated 1 transformation per exercise. So to start with, we tell you which transformation you need to apply and get you to do the analysis. And by the end of the chapter, we assume that you know all 3 transformations and we leave it up to you to pick the transformation. Whether or not you have to choose the transformation is really up to the examiners, because both kinds of questions have appeared in the past. Sometimes they give you the transformation, sometimes they don't. So you're going to need to be comfortable with both. So with that, we're going to leave this diagram behind, and we're now going to focus on section 4A, which is the squared transformation. So I've got 3 past exam questions for you in this video, and a CAS demonstration as well. So here's the first question. You can see the questions are very old, and that's because I've saved some of the more recent ones for your revision purposes. So this is from the 2013 exam. You've been given a scatter plot, and we are told that we are going to linearize the scatter plot, so the transformation is being given to us by plotting width squared versus area. So that means y squared versus x. Okay, helpful to note that. All right, now in the next question that we're going to do, we're going to actually find the equation after the transformation has been done, and that takes a little bit of work. But in this question, we actually don't have to do that because we haven't been given the original data. We've just been given a scatter plot, and we're told the output. If I put this specific scatter plot's worth of data into the calculator and apply the y-squared transformation, then what comes out is the equation y squared equals 1.8 plus 0.8 times x. One thing I want you to notice is that they've used the words instead of x and y. And that's standard in general maths, even when a transformation is applied. So much like we did with linear regression, we expect you to write a worded equation if the context gives you words for the variables. So in this case, width squared equals 1.8 plus 0.8 times area. Now, here's the question. We're told that the area is 120. Question, what is the width? So in this case, we simply need to do a substitution into the equation y squared equals 1.8 plus 0.8 times x. X is 120. 0.8 times 120 is 96. So y squared is 97.8. Now at this point, it's tempting to choose option E because that's a number that we've gotten in our calculation. But we're not asked for the width squared, we're just asked for the width. And so that means we actually need to find the square roots of 97.8. And the other thing I know is that a width is a dimension of length, and that can't be negative. So since it's positive, I will take the positive square roots of 97.8. And if you do this calculation, using whatever calculator you have, I'll just quickly pull out this calculator. I get 9.889, which is approximately 9.9, and so the answer is option B. All right, if you're just taking general maths, remember that if you have a number squared, there are two possible solutions. So let's say if a squared is 100, then a equals plus or minus root 100, which is plus or minus 10. Here, I knew that I expected a positive value, so that's why I just took the positive square roots and not the negative one. So please note, two possible solutions when square rooting. All right, let's get into the meat of today's lesson, which is where we're not given the equation, but we have to find that equation by putting the original data into our CAS calculator, and we get the calculator to do the transformation for us. So if you turn to the next page in your handout, you'll see this is a question from 2012. And they're very nice. They've given us a scatter plot. They've given us the original data. And let's see what we're being asked to do. There's a lot to read in this question. So we've got two variables, wind speed at 9 a.m. and wind speed at 3 p.m. Now, we've got a scatter plot, which suggests some sort of non-linear relationship. It's not immediately obvious. I think you'd have to check the residual plot to be sure of that. But again, you'll see in this question, we are being told which transformation to apply. This generosity will be gone by the end of chapter 4, but for now, things are nice. So we are told that we are going to apply the squared transformation to the 3 p.m. wind speed. So that means, again, it is y squared versus x. It's this equation that we are analyzing. So when we type in the data into our calculator, with 9 a.m. being the x variable and 3 p.m. being the y variable, we're going to need to type in all the y data, find y squared, and then do linear regression with y squared as the response variable and just x as the explanatory variable. So please take a moment now to type this data into your CAS calculator. It's worth going through the exercise of actually doing it. And I will now step you through the process of carrying out the transformation on your calculator. Now, I've prepared for this video, so I've already got the data typed in. If you need to pause the video, feel free to do that now before continuing. So hopefully you've got the data typed in now. I'll start with the class pad. So what you want to do is make sure that you have given your variables meaningful names. So I'm going to call my y squared variable wind speed 3 square. SQR shorthand for square. And you don't want to square every value manually. You're going to use a formula in the spreadsheet. So on the class pad, that formula is applied at the bottom with this cal entry, cal for calculation. So here I am going to type in WS3 to the power of 2 and then press enter. And you'll see the calculator squared all the values for me. All of these look like the numbers have been squared. And I've now got the two variables that I need for my model. I've got the original x variable, and I've now got the y squared variable. On the TI, similar approach. What you will want to do is give a name to the variable you want to square. So I'm going to call it WS3 squared. And on the TI, the formula is typed in at the top. So you just start typing WS3. Notice that when you start typing, a formula referencing the name of your column appears. Colon equals means definition. I start typing in my variable. Right now it's italicized. Once it recognizes the name WS3, it turns bold. Then to the power of 2. So you can use the asterisk and type in the 2. Press enter. And again, you'll see the data has been squared as expected. All right, we now need to carry out linear regression. We need to make sure we use the right columns. We don't want to do x versus y anymore, or I should say y versus x. We now want to do y squared versus x. So back to the class pad. Calc, regression, linear regression, and just be very careful about what you put into the calculator. So wind speed 9 was my x variable, and wind speed 3 square is now my y variable. Even though it's y squared, the calculator is referring to the response variable as y, so you need to feed in the squared data already. Okay. So we'll copy that. Now, be very careful with your class pad. The data that's spat out is ax plus b. You want a plus bx. All right. So you'll see the numbers are 3.3761518 and 6.588. On the TI, menu, statistics, stat calculations, linear regression, a plus bx, which is option number 4. And I called the x variable ws9 and the y squared variable ws3sqr. Press OK. And because my calculator is in exact mode, I need to hover my cursor over the cell and read the value off the bottom row here. So same values. All right, so we've now typed in the data into the calculator. I performed linear regression with y squared versus x. And what I want you to notice is they in the exam have specified the variables in worded form. Sometimes you'll have to write the word physically. Here they've done it for you. And we need to complete these boxes. Now we need to be careful that we write the numbers in the right boxes. You'll notice that it's y squared equals x times my slope plus my intercept, rounded to 1 decimal place. So the number 3.376 will round to 3.4. And my other number, 6.588, will round to 6.6. Notice there are 2 marks for this question, so 1 mark for each number. but the bulk of the work actually came from typing this data into the calculator. It actually takes a while. There's 18 values. You got to be pretty quick at this during the exam. At exam pace, 2 marks is 3 minutes. So time is tight. If you're slow typing your data into the calculator, you need to practice regularly until you're really fluent with it. Okay, so assuming that you've got this equation, we can now do part B. Part B says, use this equation to predict the wind speed at 3 p.m. So that's y, on a day when the wind speed at 9 a.m., which is x, is 24 kilometers. So it's much like the previous question. We have an equation for y squared, but we're asked to predict y. Now, one other thing to note is this question says use this equation. So I assume this means use the rounded values. Because those are the numbers that were in the equation. In an assessment, we'll be clear on what we want you to do. But if you're not told, my suggestion is use the unrounded values, and in your working, show that you have used those unrounded values by writing a few more digits and writing 3 dots at the end of your number to indicate the number keeps on going. So, our wind speed at 3 p.m. squared is going to be 3.4 plus 6.6 times 24. All right, so we do that calculation and we get 161.8. Now don't stop there, because we want the wind speed without the square. So, and again, speed can't be negative, so it's just the positive square roots. You don't have to write this, but I'm just showing you for your benefit. So 161.8, we will now take the square root, or the power of half, and we get 12.72 ... And we read the question again. We are asked for the nearest whole number. So this is approximately 13 kilometers per hour. Okay. So, big takeaway from this lesson is, if you're given data that is not linear, you can linearize it using one of 3 transformations, and the one that we looked at today was the squared transformation. There is one more question in your handout. I'm not going to go through this. If you are confident, then I encourage you to just have a quick go at this question yourself. Here's some data. There's an obvious non-linear pattern. It looks pretty parabolic to me. And here we're told this time we are applying an x squared transformation. So using this data, you need to type the data in and find an equation of the form y equals a plus b times x squared. Please note that unlike the last 2 examples, this time the x squared variable is getting the transformation and not the y variable. So I'm going to leave it to you as an exercise to confirm that you can carry out the transformation correctly with the x variable squared instead of y. And if you do this correctly, you should get option A. If in the course you don't get option A, please check your CAS calculator work, or come speak to me and we can quickly check what you're doing. If you've got any questions, Year 12s, please don't hesitate to get in touch over Teams. I'm always there to support you. And that's it for this video. So I'm going to ask you to complete this question now to confirm that you can get the result that's expected, and then please complete the assigned questions from exercise 4A by our next lesson. Thanks a lot, Year 12s, and I look forward to seeing you next week. Bye-bye.